Okay, good morning and good afternoon. My name is Marcus Holmes. I am the sales engineer here at Zyxel, and I'd like to welcome you to today's Tech Talk webinar, where I will be focusing on the user interface for our firewalls and covering the most commonly used menu items and their initial setup. Of course, during our webinar, if you have any questions, please feel free to ask, and I'll ask them at the end of each topic. So looking at our agenda for today of the topics covering, I'm going to be looking at the dashboard of our firewalls, the LAN and WAN setup, chunk and load balancing, policy routing for our firewalls, NAT/port forwarding, setting up firewall rules, our VPNs, and setting up admin accounts. So we're going to go ahead and take a look at our firewall. And I'm going to switch over to our firewall right now. So all of our firewalls from our ATP over to our VPN series and our new Usg Flex series have pretty much the same graphical user interface. So you'll see that everything on this screen will pretty much mirror any of those devices, whether you have a VPN 100, an ATP 500, or any of our Usg Flex devices. When you first log in, if you already run through the initial setup wizard, this is going to be the first page that you land on. This is going to be your dashboard. Your dashboard gives you all bits of information about the hardware, the health of the hardware, and then also give you some information about network statistics. On your left-hand side, you'll end up seeing that you have your CPU usage, which constantly updates. You'll be able to get information on your memory usage, your flash, your USB storage if you have a USB device connected up, your current and active sessions, your DHCP table, which if you hover over the number, it'll actually bring up your actual DHCP. So you can see what devices are connected up. The number of login users. So if you have admins that are logging into the device, you'll be able to see who's logged in.
Hey, Marcus,
you'll be able to see, yes.
I don't have the screen share.
Oh, you do not have the screen share. Okay. Let's see. There we go.
There,
I apologize for that. Okay, so let me backtrack a little bit here. So this is the screen that pops up when you first log into the device after running the initial setup wizard. So on the left-hand side, again, CPU usage is on the left, your memory usage, your flash, your USB, your active sessions, your DHCP table here. If you click on the DHCP table, you'll be able to see who's connected. Your logged in users, your current logged in user, any VPNs that are connected will also show up here. You can just click on the number and it'll bring up the table and you'll be able to see, who's connected up. And then we have our Ssl Vpn. So if you're using any type of Ssl Vpn to connect up, you'll be able to see the amount of users that are connected. Now, on your virtual device, this is our virtual panel. So if any device is connected up to an Ethernet cable, you'll be able to see that information as to what ports they're connected up to. Hovering over it will provide some information such as the IP address and what zone that they're connected to. Additionally, we do have the rear panel that you can flip to on the back. So if you have a console cable connected for console access, it will show right here. Under device information, it shows the system name, the serial number, and your MAC address range. Now, your MAC address range will always start with the first port. So your first port being 3F, and then it goes all the way to 45. So this MAC address range is very useful. So if you need to do any type of debugging, or if you need to register based on MAC address, it's always going to be this first MAC address here in the range. Here, of course, we have our firmware version that's reported, and then the boot status for the system status, along with the system uptime and the current date and time. Beneath that, we have our traffic statistics. So you can see a rough view of your traffic that's been pushed through the firewall over a period of time. And then, of course, at the bottom, you have your 5 latest logs, where ports are going up or down. It will actually report that information in the latest logs. So, are there any questions about the dashboard itself? Okay, moving along, let's take a look at your LAN and your WAN setup. So on the left-hand side, you have 5 icons. You have your dashboard, which is going to be this top icon. You have your quick setup wizard. You have your monitoring, and you have your configuration panel. So if you click on the configuration panel, it'll open up to your main configuration settings. And these are all of your menus for configuration. For network setup for your WAN and your LAN, you're going to go directly to your network panel and go to interface. Now, depending on the type of device you have, whether it be an ATP 500, 200, or a VPN device, your port configuration roles might be a little bit different from what you see on the screen. That's because we offer different port configurations. So for instance, with the ATP 200, you are bound to what we have in the screen here. So here we have a optional port with our SFP. This SFP can be used as a third WAN if necessary. You have your WAN 1 and your WAN 2 as P2 and P3. Now, when it comes to P4, 5, 6, and 7, you can choose what role you would like them to be set up as. So for instance, if you want P1 to be part of LAN 1, you would just select the radio button. If I wanted P7 to be part of LAN 1, I would just select that radio button here. So you have the option to choose which port belongs to which LAN for that particular port. On our higher end models, such as our ATP 800, you have the ability to choose all the ports to be a WAN or all the ports to be a LAN technically if you wanted to, because you have the flexibility of moving the ports around to however you see fit. However, on our lower end models, such as maybe our ATP 200, you're kind of bound in between these rules here. So you can only set up LAN 1, LAN 2, a DMZ, and a reserved port or zone. Now for port configuration here, you have the ability to set up your auto negotiate settings. So if you want to set it to say 100/ or 1000/full duplex, you have the ability to change the settings for that. Now on to the actual Ethernet configuration for those ports. Here we have the listing for all of our different ports or all of our different zones. So we have our SFP, we have our WAN 1, our WAN 2, our LAN 1, LAN 2, DMZ reserve. So for instance, if I wanted to come in and edit my LAN 1, I would just highlight that and click on edit. And this brings up the edit menu. In the edit menu, you can choose and set up your subnet. So this is going to be the IP address for our LAN. So we set it up as 100.1. Going further down, we have our DHCP settings. And if you don't see this option pop up, what you can do is make sure that you have your show advanced settings, because there's going to be some extra information that we might want to put in a little bit later. So under DHCP, we can choose DHCP server or we can choose none. So if we don't want to use the DHCP on the firewall, we can go ahead and choose none. However, if you want to choose the DHCP, you can put up the DHCP server or you can choose the DHCP relay. You can choose your IP address pool. You would start off, you can put it as 33, you can put it as 2, you can put it as wherever you want to start off as. And then you can choose the different pool size for this particular DHCP server. Next, you can choose your DNS optional settings for your first, second, third DNS. So you can choose a custom defined DNS, such as 8.8.8.8 or 4.2.2.1, and you can put these in for your first, second, and third. Now, what this will do is that when a client connects up to the firewall, they'll receive a DHCP address from the firewall, and the DNS that you choose here will automatically be given to that particular machine. If you want, you can use the actual firewall itself as the DNS, and you can program your own DNS settings in the DNS settings in the system object. And of course, you have your lease time. You can set your lease time for your DHCP. You can choose it by days, hours, or you can leave it as infinite, which is the default setting. Further down for your DHCP, you have the option of doing IP MAC binding. So if you enable IP MAC binding, you can create a static DHCP table. So you would just come down to static DHCP table, click on add, put in the IP address and the MAC address, and then a description. So if you have Bob's laptop as the name of the particular device, You can put in the IP address, the MAC address for that particular laptop, and that each time that this device connects, it will automatically be given that IP address. So if I put in 192.168.100.50, and I put in the MAC address for Bob's laptop, he will always get this particular IP address, and it will reserve it specifically for this particular MAC address. So that means that no other user can receive this IP address from the DHCP pool. This is very useful, specifically if you start creating policies where you need a specific device to say, for instance, we want to have a DHCP server that handles IP addresses, but we have some firewall rules or some security policy rules that are tied to a specific IP address. So if we want to allow Bob's laptop to have a priority for bandwidth management, or if we want to allow Bob's laptop to be exempt from content filtering, we can then apply a rule based on that IP address, and we can ensure that that computer always gets that IP address with the IP MAC binding. Now for the WAN, to get connected to your ISP, you would just come into the WAN and you would click on Edit. Now you have the option of changing the interface name. I've seen customers change the interface name to match which ISP that they're connecting to. So if they're using two different WAN ports, WAN 1 and WAN 2, where WAN 1 is connected to, say, Verizon, you can just put that in there. So that way you can differentiate which port belongs to which ISP. Further down, you have the option of doing DHCP on the WAN, or you can use a fixed IP address. So if your IP or your ISP gives you a static IP address, you would enter that information in here. Your IP address, your subnet mask, and your gateway. Further down, what we can do is we can enable a connectivity check. Now, this connectivity check is very, very important, specifically if you are doing a dual WAN. If you're doing dual WAN with, say, failover, you want to enable connectivity check because this is the mechanism that will determine if the WAN port is up or down. So you would come in here and enable connectivity check, and by default, it is set to check the default gateway. I highly recommend that you do not use this option because there's instances where your gateway for your default gateway for your modem will still be alive. However, connection beyond the router or modem may not go through. Therefore, we suggest that you have it check an address on the internet. You can do 8.8.8.8, or you can do any other IP address out there on the internet that you believe will be up most of the time. We recommend that you will leave these settings as default. However, you can further define the check tolerance and the fail tolerance as you see fit. Now, moving along, we're going to take a look at the trunk and load balancing because when you have your dual WAN, it does set up between the two. So your trunk is how you determine how your WAN will operate when you have two different WAN ports. So if you have WAN port 1 and WAN port 2 with two different ISPs, you have the option to do a couple of things with load balancing. So what we can do is we can create a user-defined WAN trunk. So if we do that, we would come here to user configuration and click add. And we'll give this a name. I'm just going to call this test for right now. Now we have an option for load balancing algorithms. So we have weighted round robin, least load first, and spillover. Now, weighted round robin is very unique because what you can do is, let's say that your WAN port 1 is your fastest connection. You have it coming in at 200 megabits per second. Your WAN port 2 is only 100 megs per second. So if we did weighted round robin, we can create our WAN 1 because that's our fastest connection. We would say it's active, but we would give it a weight of 2. And the reason why we're giving it a weight of 2 is because WAN port 1 is actually 2 times faster than WAN port 1. We would come down here and add WAN port 2. We would set it as active, and now the weight is 1. So what this means is that both WAN ports are active, but it's going to divvy up the traffic so that it pushes more traffic through WAN port 2 than it does 1. It's basically like for every 2 parts of traffic, it's going to send 1 bit of traffic down WAN port 2. So that's what weighted round robin does. The second option is going to be your least load first. So you put both of your WAN members in, set them to active, and then you would choose WAN port 1 is going to be your first port priority, and your WAN port 2 is going to be your second priority. However, it's going to look at whichever WAN port has the least amount of traffic going through it. It's going to then push traffic out that particular WAN port. And it's going to continue to look at both ports to determine which port has the least amount of load. Now, just a word of caution, this is not like SD-WAN, because SD-WAN works on a packet-by-packet basis. Our device with this particular setup for our load balancing looks at it on a session-by-session basis. So if the session is already open, it's going to remain on that particular link. So it's not like SD-WAN. Now, if you would like to do, what you can do is do an active-passive connection with least load first. So leaving it with active-passive means that your WAN port 1 remains active. And this is where the connectivity check comes in for the WAN. So with an active-passive setup for your load balancing, WAN port 1 will remain active. The ping connectivity check will continue to check an address out on the internet. And if that ping connectivity check fails, what it will then do is signal to the firewall that WAN port 1 is not active, and then it will put it in a passive state. WAN port 2 will then become active, and then traffic will then be rerouted to WAN port 2 automatically. So this is your failover option here. This is for if something happens on WAN port 1, it will then go back to WAN port 2. Now, I don't know if you can see this, but there's an option here that says disconnect connections before falling back. So this means that whenever the WAN port 2 is in a passive state and it's the primary connection, it will continue to send out connectivity checks to see if the port is alive. When the port reports that it is alive, it will then reactivate that port. And if you have this option up here checked, it'll then disconnect all connections on WAN port 2, set it to a passive connection, and then reactivate the routes to push traffic to WAN port 1. And then lastly, we have spillover. So spillover is basically what it sounds like if you set it to active-active. Spillover means that it will take WAN port 1, and once it's reached your spillover bandwidth, you can set your spillover bandwidth in terms of kbps. Once it hits that threshold for spillover, then you would then have it automatically switch over to WAN port 2. So that means that all traffic will go out WAN port 1 until it hits its maximum amount. And then at that point, it will activate WAN port 2. So I see that we have a couple questions here. So I'll stop here for a moment to take a look. There's a question that asks, can you speak to the differences of the firewall capabilities between devices like the ATP and the Usg Flex Series firewalls? Basically, I can give you a short rundown, but when you're looking at the differences between the Flex Series and the ATP right now, because those are the two main firewalls we have, the Usg Flex Series can be used in Nebula. That's the main selling point for the Usg Flex Series. You'll see that the capabilities between the two, the Flex and the ATP, are the same. However, the ATP has a little bit of a leg up over the Usg Flex because it has the sandboxing. So the sandboxing is going to be the security policy that allows you to scan for zero-day threats and be able to send unknown malicious or possibly malicious files into the cloud to be scanned for sandboxing to determine what it does. So on one side, ATP has a sandboxing, but it's not available in the cloud as of right now. But the Usg Flex Series can be used in the cloud with our Nebula series, but it does not have the sandboxing capabilities. A question by RW Sanders: wouldn't it be more secure to rule to MAC address rather than IP? As of right now, we don't have that option to do it based on creating rules for MAC addresses right now. I know that you can do it on the switch level, but we do not have that ability within the firewalls as of right now. A question about the challenge I have seen on setting the NSG is setting for load balancing and failover when you want as much as you can on the faster connection, but still use a slower failover when the traffic overloads the faster, and test still go into failover if the faster fails. Well, that's unfortunately, that is a problem with the NSGs. With our new Flex series in Nebula, we do have more policy routability or policy routing capabilities. That's something that was very, very much highly missed within the NSG series when it was in Nebula. However, with the Usg Flex series, we're making it more robust and we're making it more on par as a one-to-one comparison to the standalone devices. So you're going to start seeing more future updates to make it more on par with our standalone ATP and USG standalone Flex series, but you'll see that with the Flex series in Nebula. Okay, so if there's no more questions, I'm going to move over to policy routing. So policy routing can be found under network and routing. And what you can use with policy routing is a very, very powerful feature. Some of the things that you can use policy routing for is, let's just say that you have a specific device, maybe a VoIP server, or you have some SIP phones, and you want to push traffic, all traffic from SIP phones out of a particular WAN port. We've had customers that had a WAN port 1 specifically for their data, and they had a WAN port 2 specifically for VoIP. This is where policy routing comes in. So you would come over to your policy route and click on Add. And here is where you would create your policy route. So if I create one, I'm going to call it phones. Our incoming user is going to be our incoming interface. Our incoming source address is where we would come down here and select a specific address object. Now, our firewalls are very object oriented. So what you would do is you can come in here and create a new address object if it's not listed. And we're going to create an address object. So for this demonstration, we're going to call one phones. And we're going to just say it's a host. We're going to say it's 192.168.3.100, or actually we'll make it 3.150. And click on OK. So now that I've created this address object, it will now show up in the source address object list, phones. So what we're going to do is we're going to specify that anything coming from that particular IP address called phones as a source, the destination being any, because it's going out to the internet, we would come straight directly down here to next hop. Now, next hop, if you set it to auto, it'll automatically take the WAN port 1. If you select interface, you can choose which interface it will go out of. So now we can drop down here to interface and choose WAN port 2. And you would leave everything else as default and click on OK. Unfortunately, I don't have a gateway set up for WAN 2, so that's why I got this message. But basically, if I had a gateway set up, it will basically allow me to do this. It just gave me an error because there's no gateway set up. But basically, that's how you would set this up. So your source is going to be your phone address. We have it here. We hover it over, we can see over it. And then we would go over here to our next hop. And our next hop is set to P3, which is our WAN 2. So that's how you would basically set up a policy route. So this is a very powerful feature that you can use for setting up any type of policy route that's needed. If you need to bound traffic to a specific WAN port, if you need to bound traffic to any other local, you can do it as well. Are there any questions about policy routing? Okay, moving along, we're going to talk about the NAT. And in our NAT, this is going to be where you would set up any type of port forwarding or one-to-one NAT. So in our devices, port forwarding is called virtual server. So if you go into the NAT and click on Add, the first thing that you can do is choose what you would like to do. Besides naming it, we're going to call this test for the name of the policy. But our classification here is where you would choose between virtual server, which is your port forwarding rule, or one-to-one NAT. So your virtual server is going to be for forwarding ports to a specific machine. Let's just say that you have a Windows machine that has RDP set up and you would like to access it from the outside. So that would be a port forward. So for your incoming interface, you would choose what port it's going to, or what IP address it's going to trigger on. So we're going to use the main IP address, which is our WAN 1. The source IP, this is going to be the IP address from the outside. So if we want to lock it down, let's just say that we have a user, we're going to call the user Susan. Susan is going to remote in to her remote workstation, her Windows machine that's behind the firewall. Susan's coming from a specific IP address out on the internet. She's coming from her home. So if we know that IP address, we can create an address object that defines what her address is. So if Susan's IP is a host, and we're going to say that it's 172, we'll just use the internal address, but we'll say it's 172.16.21.35. Let's just imagine that's her outside external IP address. What we can do as a source IP address to lock this down is choose that particular IP address. I don't think I saved it. Let me go back here and do address 1. It show up. Okay. Not sure why it's not here, but basically it should show up here. And what you can do here instead is you can do user defined, and we can actually put that information in. So we can say the external IP address is 172.16.21.35. So we'll say that that's her external IP address. So when she's coming from that IP address, this rule will trigger. The internal IP address is going to be the internal PC that we're forwarding to. So on our network, we have 192.168.3.10. We'll say that's where her machine is at. So we're creating a rule, we're creating a tightening rule that basically specifies that whenever traffic comes from this external IP address, we're going to forward it to this IP address if it comes in on a specific port. So this is where the port mapping comes in. So the default protocol for RDP is going to be 3389. So if we do 3389 for both ports, we've now created a rule that specifies that if anybody comes from this particular external IP address on this particular port externally, we're going to forward it to this internal IP address as this particular port. Now, what you can do is something called port triggering, where you can change up the external port to kind of mask the internal port. So if we want to come in on, say, 3390, you would just hit the public IP address, :3390. And if you're coming from this external IP address, it will then translate the internal port to 3389. So this is how you would set up a regular port forwarding rule. In addition to this, you will have to create a firewall rule, because as our firewall is set up, we have two parts. We have the outside world hitting the public IP address. That's the first part. And then we have from the firewall going internally into the other part of the network. So this rule here is basically creating kind of like a passageway from the outside hitting the firewall and then going into the network. But we still need to provide a firewall rule that allows the traffic to traverse inside the network. And that's something that I will touch on when we get to the firewall section. The second option is going to be your one-to-one NAT. Now I'm going to actually exit out of this so we can clear that out. And we're going to tell this test. So for your one-to-one NAT, this is going to be for applications where the ISP is giving you a group of IP addresses. So let's just say that your public IP address is 172.16.21.10. That's the IP address that's on your WAN port. Well, let's just say they also gave you a .11, a .12, a .13, 14, and 15. You're free to use any of those IP addresses. However, you're already using one on the WAN port. So with one-to-one NAT, what you can do is take one of those public IP addresses and use that here. So your source IP address you would use as any, because you're allowing traffic from the outside coming in. When it comes to your external IP address, here where it differs from virtual server, you would set up the actual IP address for that particular one-to-one NAT. So if we're going to use 172.16.21.15 as the external IP address, that's what we would set there. We would choose the incoming interface as our WAN, because that's going to be bound to the specific ISP. So So we're going to put .15 and we're going to tie it to WAN port 1. And now we're going to define internally where it's going. So if we want to host a web server on 115, or sorry, on 1.15 as the external IP address, we can then input the internal IP address of where that web server is located. So if that web server is located at 3.50, we have now created a map that says anything hitting our WAN port, which has a .10 address, but we're going to use the .15 from the ISP as the user-defined external IP address. So if anybody comes in on that port, or sorry, on that IP address, it's then going to create a mapping directly to this internal IP address at 3.50. Now you would then change your port to accept what port you want it to come in on. So if you want regular port 80 traffic, we will put 80 for both. So in this rule, it's similar to port forwarding. However, we're creating a mapping that directly ties to one of your IP addresses in your block. So instead of using the actual direct WAN port interface IP address, we are now doing a one-to-one NAT from one of the IP addresses in the pool from the ISP. So another question that's popped up, is it possible to restrict to a single MAC address? No, right now you cannot do any type of MAC address-based rules for the NAT. That's something that's been often requested, and it has been put in as a feature request for our firewalls. I know that it is a feature that a lot of people are looking for, and we've submitted it before. So we know that it is on their radar. So we're hoping that they will actually come up with something for this. So are there any questions about your NAT and your port forwarding? Okay, so moving along, we're going to look at the firewall rules. So all of your firewall rules are going to be found under here under security policy. So under security policy, we'll take a look at policy control. Now, here is your firewall. Now, right now I have it disabled, but basically your firewall rules read from top to bottom. So your bottom has a deny rule that basically specifies that traffic from any going to any basically deny. So this is your catch-all. This is going to deny everything. Everything above it is your exceptions. So for instance, we have IPsec built-in rules. We have LAN 1 built-in rules. So this is basically your LAN 1 going to the firewall. We have rules to allow specific traffic directions.
Hey, Marcus, there are a couple of questions in the chat box itself, if you can take a look at those.
Yes, I will. Let me pull that up really quick. Okay. Okay, I'll actually answer those in a little bit here. It's not showing. It's not showing up on my side, so for some reason I can't see the chat window. There we go. Okay, so here we go. All right. I'm going to go through these at the end, and I'll answer all of them. So I see them now. All right. Thank you, Trey. Okay, so for the policy control, basically, again, it reads from top to bottom, and then your bottom is going to be your catch-all. So if we want to create a rule for our port forwarding, we have to also create a rule for traffic to come into the LAN itself. So in order to do that, we need to create a rule that specifies that traffic is going to be allowed to come into the LAN. So I'm going to create this rule. I'm going to call it port forward. And then what we're going to do is we're going to choose the source as any, and the destination is going to be to our LAN 1 because we're going from the outside coming in. We're going to leave everything, the source, the destination as is, but we're going to go down to the service, and this is where we choose our ports. So there's a list of built-in ports that you can use. So for instance, we wanted to do like HTTP, which is port 80. We also have built-in ones for, NTP, MSN, all these different things. But if you can't find something, if there's something in here you can't find, you can create a rule. So for our example earlier, we had RDP. If you put that in, that'll automatically trigger for that port 3389. However, if there's a port that you're going to be using, you can come to create new address object, so create service object. So go to create new object and go to service, because service is going to be our port. So let's just say that we wanted to use, say, 3390. We can choose our protocol as TCP or UDP. If you need to do both, you would have to create two separate rules, for one for TCP and one for UDP. So I'm going to call this RDP2. We're going to put our start port as 3390 and our second port, ending port, is 3390. So now that we've created it, we can come down to our service and come down to the very bottom, because our rule should have been added towards, here it is, RDP2. And then for your user, your schedule, you basically leave them as default. And then our action is going to be allow. So we're going to allow this particular rule coming in. So if anything comes in, going to the LAN with 3389, we're going to allow it. And you have the choice to either log the traffic or log an alert, or do neither. And then you would just click on OK, and that rule is now posted at the very top. So it's going to read it from top to bottom. So if we have that RDP rule that's coming in on 3389 or 3390, and we want it to trigger on 3390, it first hits the NAT rule for your port forward, bypasses the actual Zyxel in the front, forwards it to the internal port, and then this firewall rule will then allow it to reach its destination. So the firewall rule is going to be very handy for creating specific rules or to create your NAT and port forwarding. So you always need to set up a firewall rule anytime you do a one-to-one NAT or a port forwarding rule. Okay. Moving along, I'm going to take a look at the VPN section. So for our firewalls, we support Ipsec Vpn, Ssl Vpn, and Lttp Vpn. Now, there's going to be major differences between all three. So first, I'll start with Ipsec. So Ipsec is going to be the most secure way to connect a VPN. So if you need to do a remote worker that needs to work from home and you want them to log in to resources behind your firewall, Ipsec is going to be the best choice whenever possible. The reason is that with Ipsec, you have the highest security, you have the best speeds, and then we also have something called Vpn Provisioning. If you are using our Zyxel Vpn client, we have the option to create a configuration provision. So this means that in our configuration provisioning, instead of having to go to the client and put all the information for setting up a VPN, your phase 1 and your phase 2, you can have the firewall basically pre-configure that client. So in the client, if you open it up, there's an option to connect to a firewall. You would just put in the firewall's IP address, a username, and a password. And then once it connects, it will download the configuration for the VPN client to automatically configure it. So you don't have to worry about remembering pre-shared keys. If it's phase 1 has a specific algorithm, all that stuff's already done for you. So in terms of configuring the Ipsec VPN, you have your phase 1 and your phase 2. So your VPN Gateway is going to be your phase 1. So to create your phase 1, you would come here to your VPN Gateway and click on Add. You would enable the VPN, give the VPN a name. So I'm going to call this test. Choose your IKE version. So we do support IKE v2 for both client and site-to-site. You would put in your IP address, the peer gateway address, the IP address you're connecting to. So if you're doing a site-to-site, you would put in the IP address of the other side that you're connecting up to. It doesn't have to be our firewalls. It could be SonicWall, FortiGate, it doesn't matter. It will still connect up to other devices as well. If you're going to be doing a client-to-site, you will put the static IP address as all zeros because you don't know what IP address they're coming in from. Your authentication, you would enter in your pre-shared key. So you would choose it as see fit. You can choose whatever IP address or whatever pre-shared key you want to put in. And then finally, we would click on Show Advanced up here to choose our encryption algorithms. So you can choose your encryption, DES, triple DES, AES, your authentication for SHA, MD5, SHA-512, and then your Diffie-Hellman key group, whether it be DH1, and we go all the way up to DH21. So after you've created this information, you would click on OK, and that's your phase 1. Then you would come up to your VPN connection and go to your phase 2. You would click on Add, and then you get the VPN connection a second name. So I'm going to call this test as well. Here's where you would choose your different types of scenarios. So we have site-to-site, where you know both sides of the IP addresses for each site. You have your site-to-site with dynamic peer, meaning that you have a side that you're connecting to where the IP address is constantly changing. Then we have remote access for server and client role. So if we set it to server role, we can then set up our Vpn Gateway, select test for our phase 1, and then local policy is going to be the IP addresses that you want the client to have access to. So this is going to be your client to site. This is going to be your road warrior VPN, where you have people that have clients, VPN clients connecting in. When you choose your local policy, this is going to determine what resources they have access to behind the firewall. So if you have a specific subnet, we want to have them access all of line 1 subnet, or you have a small subnet that you created that you only want them to have access to, you will put that in the local policy. Further down again, show advanced settings to configure your phase 2 algorithms. Again, your encryption, your authentication, and your perfect forward secrecy. After you've done all that, the VPN tunnel will show right here. Now, whenever somebody connects, you will see that this button will actually change a different color and show that there's a link. So because this is a client to site, we don't really dial out if customers are dialing in. Now, if this were a site-to-site VPN, you would come here and actually click this button to actually get it to connect. So you would have it dial out. Now, one of the options you can do that I actually missed is going to be under advanced. And you have the option, I believe it's over here. Let me find it. Actually, it's on the first page, sorry. You have the option to do extended authentication. So if you want to do a situation where you have people that are using, say, Active Directory, because we do Active Directory integration, you do have the ability to set up your extended auth methods. So you would just choose your extended auth method, and then you would choose if you're using your AAA method. But that's something I will go into in another webinar when setting up your AAA authentication. But you do have the ability to set that up as well. So that's the Ipsec Vpn. The second option is going to be the second most secure option. It's going to be Lttp over Ipsec. A lot of our customers choose this option because it's natively supported in Windows, Mac OS, Android, and iOS. So it's very easy to set up. You don't have to worry about installing any additional software, whereas with Ipsec you do. However, we do actually have a way to connect with Ipsec on mobile clients by using certificates or a pre-shared key. So it does make it a little bit more easier, but a lot of people tend to gravitate more towards Lttp. So with Lttp over Ipsec, what you need to do is there's a command that you have to enter in the CLI that basically creates the default Lttp over Ipsec connection for the VPN. And then once that's created, what you can do is come down here to Lttp over Lttp VPN, enable it, and that default Lttp connection that's created through the CLI will show here in the drop-down list, because what you're doing is you're encapsulating Lttp through Ipsec. So once you've selected that rule, then you choose your address pool. So the main difference between the Lttp is that the Lttp actually provides an IP address to the clients when they connect up. So with Ipsec, instead of using their own local IP addresses, Lttp actually provides the clients when they connect up with a subnet. So you would have to create your own address pool. So again, you would just come to create new address object. and you can create an Lttp pool. You can under address type and put it as a subnet, and then you can make the pool, 10.10.10.0.255, and that will be your pool. So that when users connect up with Lttp, they'll be given the IP addresses in this subnet. Additionally, you have to create users for your Lttp. So we're going to get to that in just a moment on creating admin accounts and user accounts. But once you've created those users, you can select the user when they connect in, because in order to connect to the Lttp, they have to sign in with a username and password. And that's done either through Active Directory or a local database in the local user database on the firewall. You then define your custom-defined DNS or your ISP-based DNS, and that's pretty much it. Lastly, there's going to be the Ssl Vpn. This is going to be the least secure and the least fastest of all three options. So with Ssl Vpn, it's fairly simple to set up on the firewall. You would just click Add, and then you would select what users or what user groups have access to the Ssl VPN. So you just select it and click the arrow button to move it over. And then you have the option for either full tunnel mode for enabling network extension, which allows you to do, access all the device or all the subnets of the VPN. And then you can also choose to force all clients to enter the Ssl VPN tunnel. So this would choose it to not do split tunneling. It'll force all the traffic to the VPN. And then under network list, you choose what addresses the clients have access to when they connect with the Ssl VPN. So for instance, if we want them to only have access to the LAN 1 subnet, we would choose that, and then that will be it. Now with Ssl VPN, you would have to download additional software called our Secu Extender, and it's a client that's installed on your device, on your Windows or Mac OS device. The Mac OS version is licensed, whereas the Windows version is not. So basically, a screen pops up, you enter in the IP address of the firewall, the username and password that was created for that particular user, and click connect, and it'll automatically connect to the Ssl VPN. Now, out of all three, we highly suggest you go with the Ipsec Vpn, primarily because of the IPv2 integration. That's going to help you pass any type of PCI compliance scans. So with Lttp, there's a possibility that you can still pass, but we've seen scans come up with fail with Lttp over IPsec. So we highly suggest that when choosing out of the three VPNs, if you want the most secure and you want something that will be able to pass your PCI compliance scan, you definitely highly suggest you go with Ipsec Vpn. Is there a chance the Ssl VPN to be hacked? I don't see it being hacked unless either someone's sniffing traffic on your network and you have, let's just say that you have certificates installed on both sides and someone's sitting in the middle scanning traffic. But again, Ssl VPN, only because it's using TLS 1.2, well, we just upgraded to TLS 1.2. It's still secure, but we still suggest using IPsec over VPN because you have a higher chance of using, you have a better chance of using higher encryption algorithms that make it very much more difficult to decrypt the traffic. Okay, finally, we're going to take a look at admin accounts and account generation in general. So that can be found under our objects. So under object and user group, we can create new users. So if we want to create a new admin user, I can come in here and type in the username. I can put my name in there. I can put myself as an admin. Then you put a password. And then you can choose an email if you want or a mobile number. We do offer two-factor authentication with Google. And this is something that I will cover at a later date or do a full kind of walkthrough of our Google authentication integration. But just know that that is an actual option. Now, if I don't want to make myself an admin, I can make myself a regular user. So a regular user is going to be used for authentication such as web authentication or LTTP over IPsec or Ssl VPN as a user. However, if I want to do something a little bit more different, let's just say that I want to make a limited admin. A limited admin basically gives read-only access. So if you wanted to provide one of your technicians access to a firewall to let them only visually see and read what's going on but not make changes, you can make them a limited admin as well. We do have options for guest accounts and also external user and external user group. These two options at the bottom are primarily used when setting up your AAA, your AAD server settings. And your guest account is going to be for your web authentication. Furthermore, what you can do is you can create multiple users and then tie them to a group. So if I were to create, I'll put myself in a group. We'll just say that this is me here. I'm going to save this. And then I'm going to create one called Bob and click on OK. So now we have, oops, let me do it one more time. Save. OK. So now we have these two users, Bob and Marcus. What we can do now is create a group. So we can bind these two users to a specific group. And this is very useful because let's just say that you have multiple users that you created and you want to assign them to a group. Let's just say that both Bob and I are part of the sales group. So now we've created a group we call sales. We can move myself and Bob over to this particular sales group. So anytime we want to create a rule, so for instance, if we have a policy routing rule, we can define that sales group instead of typing in each and every individual name one by one. We can group them all together into one address or one group object that specifies those particular users. Next is going to be the settings for these particular users. Now, we have the option to have them automatically renew the lease time. We can do user idle timeout detection. So enabling this, if a user is logged in through web authentication or they're logged in as an admin user, there's no idle timeout. Basically meaning that as an admin, you have 3 minutes. If you're idle, it kicks you out and you have to log back in. Now, as far as login security, we have the option to set it so that you can change the passwords every 90 days or every 180 days or 365 days. We have the option to set up the complexity of the password. So if the password doesn't meet specific complexities, then it will basically require you to re-enter it until it's met. Finally, looking at the user login settings, we do have the ability to limit the amount of accounts that can be used at one time. So for instance, an admin account, if I set this to limit the amount of simultaneous logins for the admin account, that means that the admin account can only be logged in with one. So if I type in the admin and the password and I log into the device to administer it, nobody else from the outside can come in and try to use that same user account to log in. However, if I limit it to 2, that means that I can have 2 admins on at the same time. The same thing goes for regular users. You can do the same thing for regular users as well. And then lastly, there's a retry limit. So by default, if you try to enter in a password for an account and you fail 5 times, your IP address gets put on a list and you're locked out from making any more further attempts for a default period of 30 minutes. Now, if this happens to you, if you typed in the password wrong 5 times and you made a mistake and you want to get back in, of course, you can reboot the firewall because it clears that list out. However, this is a good practice to have so that you can prevent anybody from the outside from trying to secretly guess your password. All right, and then that's going to be it for the screen share. I'm going to now answer more questions that came up. Okay, so I'm going to start with the questions that came in through chat. Okay, so there's a question about active passive WAN. If I'm using WAN 2 passive just for a SIP trunk, how would I set that up? I'm hoping that kind of was made clear after I kind of went over that when I talked about the different setups for policy routing. But what you can do is you can set up a WAN trunk with WAN port 1 and WAN port 2, and then you can use the policy routes to facilitate the traffic to go out WAN port 2, specifically only WAN port 2. So again, that's just going over here to your network, going to your routing, And then basically here we would have like our SIP phone going to WAN port 2 as the next hop. Okay, so there's another question that comes up. Why is there two ways to specify the external IP address? For instance, source IP address and external IP address. How are they different? Why do we use both? So I believe you're talking about this section here, correct? Where you have the option of doing both the source IP and the external IP address. The reason why this is here, unfortunately, is mainly because of the NAT rule. I don't know why it's not taken away, but on the NAT rule, your source IP address is always going to be what's coming from the outside or where you're coming from. And then the external IP address is going to be what's defined on the actual WAN port itself. So your external IP address, again, for your one-to-one NAT, is going to be one of your IP addresses from your IP pool. The source IP address is going to be where the user is coming from. Let's see, there's a question. Does that mean the outbound will also go from that IP address in one-to-one NAT? Yes, because when you set up your one-to-one NAT, there is something called your SNAT. It's automatically going to generate a source network address translation where it automatically makes that traffic when it leaves. When you're coming from the outside, you're starting from the outside coming in. So let's just say that you have a one-to-one NAT. You have it set up so that if anybody hits that IP address from the outside, it hits the server, it will then come out as that IP address. Now, if you want specifically for that, any traffic generated from that machine to go out of the WAN port with that IP address, that's a little bit different. That's going to be set up in your routing, and we'll use this as an example. We'll come here to edit this. So we're going to say that the source address is our phone server, okay? And we want it to always go out with a specific IP address. We would come down to source network address translation. And our source network address translation will allow us to use one of the IP addresses in the pool. So if you create an address object that specifies that particular WAN IP address from your IP pool, you can come down to the SNAT and create an address object for that particular IP address that's in your pool, and then put that as your SNAT for your source network address translation in the rule here. So that means that anytime any traffic leaves from this IP address going out of the internet on WAN port 2, it will leave with an SNATed interface IP address. Instead of using the outgoing interface, it will then use whatever IP address you specify here that's in your IP address block. Okay, and I think that we covered all the chat questions, and I'm going to the Q&A section. Question about two-factor authentication. What if you do not have internet access at all? I will cover that in a future webinar. We do have the ability to not have internet access because of the way that it is set up. It has, from my understanding with the Google Authenticator, it has the seeded values already in, on the firewall itself. So therefore, it knows what codes will be generated. So you don't have to have internet access. Question, can you cover the reset link? Can you be a little bit more specific about the reset link? I'm not exactly sure what you mean by the reset link. I'll come back to that question. Oh, user account. Okay, perfect. Okay, so under the user account, here we go. Where was it? Give me just a second. I may have missed that, and I do apologize. I'll have to look into that reset link, and I'll tell you what, at the end of this, I'll leave my email, and we can actually talk about that in an email. Okay, I'm sorry. Here, this is what you're talking about here, the password reset link. Yeah, I'll look into that and provide you some information. I think we have a walkthrough on it, and I can talk to you about that via email. I've never actually used a password reset link before, but that's something that we can kind of discuss afterwards. One of the questions is, if you enable 2FA and you lost internet connection, how will 2FA allow you to log on? Again, that's going to be covered when I go over the two-factor authentication methodology. But my understanding, again, is that when you use Google Authenticator, it creates a random seed number of what's going to be generated by the 2FA. So it automatically knows what's going to be authenticating. So if you're logging in locally, you won't have a problem. If you're trying to log in externally, it should be the same thing. It should already know exactly what keys or what numbers will be generated by the seeded number inside the firewall that it's created. Okay, so if you guys have any other questions, please feel free to ask. Okay, I guess if there are no more questions with that, we'll go ahead and close out this webinar. I do thank everybody for attending. I will be covering a new webinar next month. It hasn't been completely decided yet, but I do know that there has been a lot of interest in Google Authentication, so that could be the next one that's coming up or may be covered at a later date. But again, thank you for joining, and I will see you on the next webinar. Thank you for attending.